Hi, and welcome to the Metals versus Nonmetals virtual lab. In this lab, you will determine some of the properties of metals and nonmetals, and metalloids to some extent, through a series of experiments. Now, by this point, you should have already completed the pre-lab, which helps you to understand the purpose, what are properties, and how do we find metals and nonmetals and metalloids in the periodic table. Now we're moving on to collecting data. So if you were in the lab and doing this in person, what you would be expected to do, or what you'll be given, firstly, are samples of aluminum, carbon, lead, iron, sulfur, magnesium, silicon, and zinc. And you would test their physical properties by looking at them, their color and describing it there, their texture, is it rough or smooth, their luster, so is it shiny or dull, and that's just by looking at it. Now for malleability, remember malleable means that it either bends or dents if you put some sort of physical pressure on it. And brittle means it's going to crumble or break if you put physical pressure on it. So so you would bend it or try to bend the substance, and if it bends, then it's malleable, and if it doesn't, it's brittle. The last one is conductivity. So we're talking about electrical conductivity. If it is a conductor, then the conductivity meter will beep or a light will go off. If it's an insulator, there's no, so for a conductor, electric current passes through, and that sort of allows the conductivity meter to beep or a light to go to turn on. Whereas if it's an insulator, there's no current passing through it, and therefore the conductivity meter will not beep or no light will go on. So what do you have to do in this first part here to test the physical properties? Well, all you need to do is click on the video. So let's do for aluminum, and you'll use the video to observe the color, texture, and luster, and then pay careful attention to the tests that are done for malleability and conductivity. So let's look at this first video for aluminum. So I'm going to pause it right there. So a couple of things, you look at it and you can see that aluminum is shiny, it's silver, and it looks smooth. So I'm going to go ahead and type that in here. So in terms of color, it's silver. Texture, it's smooth, doesn't appear to be rough, and then it's shiny. So luster describes shininess. If it's not shiny, if light's not reflecting off of it, we would say it's dull. In this case, it's shiny. Now we're going to move on to malleability. Now notice that in this video, this person was able to bend the aluminum. So that means that it's malleable. All right, now this person will do the conductivity test. And you hear a beep there, so that tells you that it's a conductor. If you don't hear a beep, then it's an insulator. So you would fill out this table for each of the elements using that same procedure. So you're filling out the physical properties that you observe by clicking on the video link. All right, so in data table 2, you are going to observe the reactivity of these elements with acid, specifically HCl, hydrochloric acid, which is the acid that's found in your stomach, actually. Okay, so just like with the first one, you're going to watch a video, but instead of watching a single video for each element, you're just going to watch one video for all of them. So you can click on this and it'll take you to the video. And in the video, you will see that these are the elements you'll be testing. Whoops, let me go back. Aluminum, carbon, lead, iron, sulfur, magnesium, silicon, and zinc. And what this person will do is they will add a drop of HCl to each one, and you're observing the reactivity. So automatically you will notice some things. Now, you're going to record your observations, what you notice, and then you're going to use that to describe the element as very reactive, somewhat reactive, or non-reactive. So I'm going to model again for you aluminum. So here's aluminum. I noticed with this one that when the person added the HCl, there was no bubbles and it did not dissolve. So I could say something like, so there were no bubbles. Aluminum did not dissolve in the HCl. So those are just my observations. And now I'm going to use these to determine if it was very reactive, somewhat reactive, or non-reactive. And in this case, since I didn't see any bubbles at all, I would say non-reactive. Okay. Or not reactive. So that's what I'm looking for here, your observations, and then also whether or not you think it's reactive. Once you're done collecting your data in both data tables 1 and data table 2, then you're going to move on, of course, to your post-lab questions. And you're going to use your data table to help you answer question 1. So you're going to look up the elements on the periodic table to identify each one as a metal, non-metal, or metalloid. One way that you could write this, so one way you could do this is just list metal, and then every element that's a metal, you can either write out the name, like, oh, aluminum is a metal, comma, whatever other metals there are, or you can write out just the symbol. Al is the element symbol for aluminum. So you would do that for the metals, the nonmetals, and the metalloids, also known as semi-metals. Okay, so that's one way to organize it, or you can organize it however way you want, but essentially what I need to know is which ones are metals, which ones are non-metals, which ones are metalloids. The next one is to rank the tested elements from the most active metal to the most active non-metal. So active is just the same as reactive. So if you go back to your reactivity data, and remember, you kind of have to align which one is which. So this first one is aluminum, the second one is carbon, and so on. Let's say, for example, this one is very reactive and that one's very reactive, right? Well, the question is, you also need to consider if it's a metal or non-metal. So if this is a metal and it's the most reactive, you're going to put it here. So let's say that I'm going to call that first one X. So you're going to put that one there because it's the most reactive metal. Whereas this one, let's say this is the most reactive non-metal, I'm going to call that Y, you would put that one here. And then you would kind of go into the middle. Now, as you get towards the middle, things can get, there's some that kind of have similar reactivities. Just put them next to each other. It doesn't really matter on the order so much as long as you're close. So you're trying to order them from the most reactive metal on the left, most reactive non-metal on the right, and then in the middle you're going to have non-reactive things that do not react, okay? So then the last part is which one element was a metalloid. You fill in the blank here, which of these was a metalloid, and then which properties are similar to metals and which ones are similar to non-metals. So in order to do that, you need to go back up to the properties list, and what may be helpful is to color code anything that's a metal in, let's say, a blue. So what I can do is use the cyan for anything like, oh, this is a metal that's going to be in blue. Carbon, let's say that carbon is a non-metal. I'm not saying it is or it isn't. I would highlight that in yellow. And then highlight all the metals and non-metals in yellow and blue and leave your metalloid alone. Don't highlight your metalloid. And then go back and compare the properties that you have so you can see, well, which properties do metals have, which ones do non-metals have. And that will help you with this question here, because once you've done that, you will then compare all the properties of your metals to the property, the properties that metals have in common, and to the property of that metalloid that you're looking at. And anything that the property that the metalloid possesses, that metals also possess, you would put it here in this box. Any property that the metalloid possess that non-metals possess, you put it there. Okay? Hope that kind of sort of makes sense. But again, I'll be more than willing to help you with that. So this video sort of just wraps up what you'll be doing in the lab. If you have any questions, as always, send me a message in Schoology. Have a quality day.